Okay, we're good one? Okay, sweet. So this is, it's a pretty short standard. All of these problems are going to be solved the same way. So notice here, we have some equations. In the last standard, we didn't always have an equal sign, but now that we do, we're going to be looking at how to solve those. So some of these are pretty easy. So like number 1, what is x equal? Yeah, x is 2. Okay, great. Hopefully, some of these we can do in our heads. Might even be able to do number 2 in our head, but let's go ahead and look at the longer, more reliable process. So all of these problems are going to be solved by rewriting the two sides of the equation so that the base is the same. So the base is 3, the base is 9. Is there a way that I could rewrite one of them so that the base is the same as the other? Turn 9 into 3 squared, exactly. So if I make this 3 to the 2x, then I can make this 3 squared. And so now basically the idea is that we have 3 to a power equals 3 to a power. Like it's 3 to something equals 3 to something. So since the base is the same, then that means the powers must be the same. Like we must be raising them to the same exponent. So we're just going to say that 2x equals 2. What we're doing here is we are setting the exponents equal. And that's what you should say too. You should not say that we're canceling out the 3's, because we're not. The 3's are not going anywhere. They're still there. What we are doing is we are setting the exponents equal. Saying that we're canceling out the 3's is not good math language. So we're not going to do that. Once we set the exponents equal, we can just solve whatever equation is left. In this case, it's pretty easy, right? We're just going to divide both sides by 2. X equals 1. But yeah, so get the same base, then set the exponents equal. It's going to be our steps for all of these. So number 3 here, is there a common base that I could get both of these numbers to? Yeah, Vivian, you're shaking your head. You're correct. So this is 3 cubed to the 2x plus 2. This would be 2 cubed. We cannot get these bases to match. This problem is not impossible to solve, but it is impossible to solve without logarithms. Solving equations with logarithms is not standard 7, it is standard 10. So good news for you guys. We don't need to solve this one today. Happy Monday. All right. Okay, so we'll leave that one for next week. So what would you say is a good common base for number 4? 3. So 27 is 3 to the what? So 3 to the 3rd to the x minus 2. 1/3 is 3 to the what? 3 to the negative 1. We want to go ahead and deal with that right there. What do I do with those powers? Multiply, yeah, so this is 3 to the 3x minus 6. Make sure to distribute. Equals 3 to the negative 1. Now I'm just going to cancel out the 3's, right? Now, what am I going to do? Set the exponents equal, yes. Set the exponents equal. I'm using up a lot of space here. So 3x minus 6 equals negative 1. And now we just solve. We don't have to get a nice number. In this case, we get 5/3. That's okay. Not always going to work out to be able to. So when you're finding a common base, you basically just want to think about the smallest whole number that has a good sort of exponent relationship between these two numbers. So for number 5, what would you guys say is a good common base? 5, yeah. So you might think like, oh, I could use 25 as a common base. You could, but 125 is 25 to the 3 halves power, and that's kind of gross. Like, we don't really want to go out of our way to use fraction exponents if we don't have to. So number 6 will be a good common base. For number 6?
Oh, number 6, though.
Yeah.
8, 4.
2. 2 would be better because I can go from 2 to 16. 2 to the 4th is 16, whereas I would need to do 4 squared is 16, but it's 4 to the 3 halves that equals 8. And so if I'm messing around with those fractions in there, that's going to make it get pretty ugly. So 2 would be a better one for that, just because it has a good relationship with both 16 and 8. So what about number 7? What's a good common base? You can shout it out. 2, yeah. 2 would be our common base for number 7. What about 8? 3, yeah. And what about number 9? 3. Number 10? 6, yeah. So this one's a little weird looking, but that is 6 cubed. 216 is 6 cubed. So yeah, 6 would be our common base. Number 11? 2. And number 12? 9. 9 would work. Yeah. What number would also work? 3. Yeah, so 3 or 9, because 9 squared is 81, or this is 3 squared, or 3 to the 4th. So that would both of those will work pretty well. Yeah. So we're just thinking of, again, the smallest, a nice small number that can be raised to a power to get either one of those. So let's look at number 5. What did we say our common base was for number 5? 5, yeah. So 25 is 5 to the what? 2nd power, yeah. And then 125 is 5 to the 3rd power. Notice how I'm using parentheses here just to keep everything straight. We're going to multiply here. We get 5 to the 2x plus 5 to the 3x plus 12. What do we do now? Set the exponents equal. Once the base is the same, we just set the exponents equal. And now we just solve. We get x equals negative 12. Okay, questions on any of those? The process should be a very straightforward one. It's the same for every one of these problems. Get the basis to be the same thing. Once you do that, set the exponents equal, solve the equation, and then you're done. Let's do numbers 6, 7, 8, and 9. We can work together. Oh, okay.
So I took okay, 3, and it's 6, and it's equal to 1, right? Yes. I don't know, probably. I think it's positive 3. Oh. Much easier than that. Let me stop. Okay. Oh, I think I forgot to buy. No, I did not. I just, yeah. It was, okay. I think I can do that. I'm not sure. Yeah.
Another couple minutes here.
Is it until 9, right? No sense. Oh, no, I don't mind actually, unless it's contained. That one's over the top. Yeah. This is one person like that. No. I think this is the one
Is 4 to 0?
you'll have to.
Yeah.
If I did this, would this be acceptable? So when you're going
Yeah, you want to
on
say this.
resources, everything kind of just gets put in to keep you alive. So it makes like you're lucky not to show you guys.
Oh, yeah.
So it can make
Yeah, this is a lot
it
of,
can
it's
make
like,
explain things like complicated brain stuff, like math. That's hard to do. Yeah. Because I'm recovering after the cat accident. Yeah, it's getting better.
yeah.
Now it's kind of oh,
Any hours you stay there?
9. Close to the
Oh.
I'll take like another 30 seconds to a minute, and we'll check together. Feel free to check in with people in front of you, behind you. You guys did the same thing. All right, you guys. Let's take a look. So for number 6 here, 8 is 2 to what power?
Third.
The third power, yes. So, and then 16 is 2 to the 4. Okay. So as far as when we're setting this up, right, I can write it as 2 to the 4th to the x, or I could just recognize this is 2 to the 4x and multiply them at the first step. That's fine. Same thing here too. If I recognize, okay, that's 2 cubed, so I just need to distribute that. So this is 2 to the 3x plus 3 in one skipping step. That's fine. As always with skipping steps, it can save you time, but also it's easier to make mistakes. So, that's the it's a two-edged sword, Set the exponents equal. It x equals 3. Wait. Okay, so we rewrite 8. How do we rewrite 8? 2 cubes. And then how do we rewrite 1/2? 2 to the negative 1, yeah. So I've got 3 minus 6x equals negative 1. Same thing there, right? If I want to multiply in my head and then skip ahead and say the exponents equal, I can do that. I think we get 2/3 for this one, is that right? Yeah. Okay, so how do we rewrite 9? 3 squared. And then 27. That's 3 squared. Alright, so the biggest thing with these is just watching out for arithmetic errors, silly mistakes, stuff like that. Really easy to make. And then the other most common mistake here, by far, most common mistake in doing a problem like this. What happens with these exponents? We add them. It's really easy to kind of get in the zone and see, oh, it's 3 times 3, so let's multiply the exponents. Nope, properties of exponents say we need to add them here. It's by far the most common mistake. I see it all the time. So I'm adding them together and doing this. So I got 4/10 or 2/5, negative 2/5. Yeah, and again, we're getting some weird kind of like fraction answers here. That's totally fine. It might be difficult to plug them back in and test them just because of the nature of these numbers, but we check our work. It's okay to get fraction answers. Okay, and so this one here, this one's a little strange, right? Because I get 3 to the 6x plus 4 equals 3 to the 6x. So I get 6x plus 4 equals 6x. Right here is early enough to recognize that there is no solution. We could also take it one more step and say 4 equals 0. Okay, 4 does not equal 0. The correct answer here, the way that we should say it, is no solution. So sometimes there's different ways to format things like this. This is different than undefined, different than not applicable. We would say no solution. Questions on any of those?
Actually, I was here for 3.
Yeah. Great question, Tony. So for 3, because we can't get the same base, we use logarithms, which is standard 10.
Okay.
Yep. Cool.